Hello, I am Dr. Gaurav, Associate Professor in EC Department. Today I have discussed Lecture 4, Rhombic Antenna and Folded Dipole Antenna. And this is a very important topic in AKTU purpose and AKTU end term examination. This is very important topic. What is rhombic antenna and what is the use of folded dipole antenna to maximum power transfers to to antenna to the loads. So this is very important topic, rhombic antenna, or we can say this is a another terms we have to be describe rhombic antenna is what is the non-resonant antenna. So if someone is asked what is the meaning of non-resonant antenna, or you can explain the non-resonant antenna, so you explain the rhombic antenna. So what is the meaning of non-resonating antenna, or what is the meaning of rhombic antenna? So rhombic antenna is a non-resonant antenna. What is the meaning of non-resonant antenna and resonant antenna? So this type of antenna does not having a resonant frequency, and so this type of antenna is called the resonant antenna. So this type of antenna is called the non-resonant antenna, and non-resonant antenna having a features no resonate frequency. First one is the no resonate frequency in a wideband or in a wideband. So this is the basic feature of non-resonant antenna, is no resonate frequency in a wideband. Second one is no transverse waves or reflected wave occurs this type of antenna. Third feature is this type of antenna having a only to be transferred by the load impedance matching. So load impedance matching is required. So while load impedance matching is required because the maximum power transfer. So in this type of antenna, non-resonant antenna, we required a non-resonant transmission line. So what is the meaning of non-resonant transmission line? So this is a transmission line and this is load, and we connected the signal here. So this type of structure is called the non-resonant transmission line structure, where the impedance of this line, if I can say this one is 300 ohm or 600 ohm or 900 ohm. So if we transfer, so how much power is to be radiated from this antenna to the load? So this is also be matched with the characteristic impedance of this transmission line. And fourth one is, in this type of antenna, the reflected wave, if I already mentioned, the reflected wave does not occurs. So reflected wave does not occurs in that particular transmitting antenna. So all of the wave, RF wave, is to be converted into the heat flow. So this is the main feature of non-resonating antenna. So no resonant frequency in a wideband to transverse or reflected wave does not occurs in this type of antenna. Third one is load impedance matching is required, and in this type of, if reflected wave does not occurs, that means, so how this, if the impedance is mismatched, so most of the power is to be converted into the heat. So heat dissipation is, in this type of antenna, heat dissipation is here with respect to the reflected wave from load to the source. Second one, so rhombic antenna is a non-resonant antenna which is capable of satisfactory over the entire range of frequency, high frequency band 3 to 30 megahertz. So that means this type of resonant antenna is to be transferred or receive that particular frequency or communicate between the two antennas in the range of 3 to 30 megahertz. So next feature is, this is the main construction diagram of rhombic antenna. So this is the feeder cable. So where the receiver is to be connected or transmitter is to be connected. If this antenna is to be received that particular frequency, so this is a receiver. If we transmit a signal via this rhombic antenna, so we connect it to the transmitter. So this is a feeder cable. This is a 2V type antenna we have to be associated here. This is V type antenna. So what is the design consideration here? So if I can say you have to design a rhombic, non-resonant rhombic antenna for 20 megahertz frequency. So design parameter are, what is the design parameter? What is the meaning of design parameter? What is the meaning of design parameter? Design parameter is that parameter. So by using these parameters, we have to be design and construct the rhombic antenna. So first one is what is the height, mount height h. Second one is the tilt angle theta. Third one is the rhombic antenna length L. Fourth one is the load impedance ZL. This is the load impedance ZL. So load impedance ZL. So mainly this is the 4 design parameter to construct the rhombic antenna in a particular wireless communication in the range of 3 to 30 megahertz. So this is a non-resonating antenna. I already discussed what is the meaning of non-resonating antenna, because this type of antenna no resonant frequency and no reverse wave is to be here, or transverse wave is to be here, or reflected wave is to be here. Only the forward wave is we have to be transmitted. And if the this load impedance is mismatched, this type of antenna, so we have to be construct here. This is the design parameter of rhombic antenna, and this is the radiation pattern of rhombic antenna. So what is the salient feature of rhombic antenna? High directivity. So this is used for high directivity. And one more feature we have to be included in a non-resonant antennas, because this is a unidirectional antenna. That means, what is the meaning of unidirectional? So no back lobe occurs in that type of antenna. So if I can say half wave dipole is a resonate antenna, so what is the radiation pattern of half wave dipole? So that means this is not a unidirectional, because they transfer and receive the radiation pattern on the both the direction, forward and reverse direction. But in this type of antenna, non-resonant antenna, this is the main feature is, this is unidirectional antenna. So this is unidirectional antenna. If I can say this is a unidirectional antenna, so the gain is or directivity is high. So this is the length L. So we can say this is a length L having a radiation pattern in that particular direction is there, and this is the minor lobe, and this is also in the direction of this antenna is to be, this theta and L is to be designed where all the radiated field in the unidirection. So this is the another lambda by 4 direction. This is the lambda by 4, this is lambda by 4 or lambda by 2. So we know that what is the radiation intensity of whole of the this whole of the this rhombic antenna in the direction of array axis. So we can say the half power beamwidth is reduced. So in this case, half power beamwidth of this type of antenna is reduced, which increase the directivity or gain, and in this type the efficiency also improves, and front to back ratio FBR also high, because the no back lobe is occurs in opposite direction. You can see that in this direction no power is to be wasted. So we can say what is the FBR? FBR is the ratio of power in the directive direction upon power in the opposite direction. So we can say the power in opposite direction is very low or zero. So that means FBR of that particular antenna or non-resonating antenna having a unidirectional pattern is to be high. So this is the salient feature of rhombic antenna. So rhombic antenna basically we have to be used to design a unidirectional antenna to having a high directivity and gain, and the high efficiency, a high front to back ratio, and the low half power beamwidth, or we can say BWFN, that means beamwidth of first band. So what is the design parameter of rhombic antenna? We already discussed. This is the tilt angle theta. What is the length of that particular wire? The height above the ground plane h. This is the main parameter to design a rhombic antenna. So what is the design equation? So first design equation to solve the what is the antenna height, height above the ground plane. So we have to be design that. So we solve this antenna for maximum directivity. We have to be achieve where this height is to be lambda upon 4 sine alpha, where sine alpha is equal to 90 minus theta. So what is the meaning of alpha? So alpha, you have to just see that. So this is theta, this is alpha, or we can say theta plus alpha is equal to 90 degree. So theta is equal to 90 minus alpha. So this is the first design tilt angle we have to be design. What is the tilt angle? Theta is equal to 90 minus alpha. And what is the height? So this height, how we have to be calculated? Lambda upon 4 sine alpha, or we can say sine alpha. So in terms of theta, which one is lambda upon 4 sine alpha, or we can say sine 90 minus theta. So we know that sine 90 minus theta is cos theta. So h is equal to lambda upon 4 cos theta. So suppose having a wavelength is 2 meter, we design a rhombic antenna having a wavelength is 2 meter. So and the theta is tilt angle is 60 degree. So what is the height of h? That means height of above the ground plane. What is the height of that? We have to be install that particular V antenna, 2V antenna or rhombic antenna. Which one is? We easily calculate 2 upon 4 upon cos 60 degree, or that means 1 by 2, or we can say cos 60 is 1 by 2, that means 1 meter. So what is the h? H we already calculated. And what is the h? H is 1 meter for a wavelength of 2 meter. If we transmit a signal having a wavelength of 2 meter and the tilt angle is 60 degree, so easily we have to be calculate the what is the height above the earth of that particular rhombic antenna is to be 1 meter. So we easily calculate it. So one design parameter is already I have discussed. Second design parameter is what is the length. So this length, how we calculate it. So this is the second design parameter. So what is the design parameter? Second design parameter, what is the rhombic antenna length, which one is dependent upon lambda upon 2 cos square theta. Or if we put it theta is equal to 90 minus alpha, or we can say lambda upon 2 sine square alpha. So we easily calculate what is the length of wire, copper wire, we have to be if we design a rhombic antenna. So this is the angle theta, elevation angle or tilt angle, we have to be calculated by the theta is equal to 90 minus alpha. This one is theta is equal to 90 minus alpha. We already calculate by this. And what is the height? We have to be calculated by this. If we put it L is equal to lambda upon 2 sine square alpha, and some coefficient we have to be taken for, because this length is not a effective length. So we calculate what is the effective formula. So we multiply by K, where K is 0.74 for sinusoidal distribution. That means why we multiply by K? Because the length is not a physical length. So what is the actual length? So actual length is reduce the physical length, which is less than the physical length. So we always, what is the actual length? Actual length, which one is equal to physical length into K, where K is the designing parameter. So that means what is the average radiation is to be received by that particular length. So we multiply by 0.74. So we easily calculate the what is the length of rhombic antenna, lambda upon 2 cos square theta, or to that means if we calculate the is length in terms of the tilt angle, so lambda upon 2 sine 90 minus alpha is cos, so that will cos square alpha into K. So this equation is here. So that means if you want the length of rhombic antenna in terms of the tilt angle theta, so we easily calculate it by this formula, lambda upon 2 cos square theta into K. So what is the advantage of this rhombic antenna? So lastly, we have to be how we what is the advantage of the rhombic antenna if we use in a transmission line, or we communicate the one devices to the other devices. So first advantage is the rhombic antenna is used for wide frequency range 3 to 30 megahertz, or either transmission or reception. So this type of first advantage is this antenna is to be used for very wide frequency range 3 to 30 megahertz. Although some changes in gain and directivity and characteristic impedance to occurs in the change operating frequency, these changes are small enough and to be neglected. That means what is the meaning of this? The directivity and the characteristic impedance of the transmission line if change, so most of the power is to be converted into the heat form, which is not useful for communicating purpose. So this type of challenges we have to be here. But if we perfectly match this transmission line to the load, so that means most of the power is to be transmitted to the load and we receive the whole of the signal. But this type of changes which has to be very small, so we neglect it. That means very small. If I transmit a 1 watt power, so 1 microwatt power is to be converted into the heat form. So we can say this type of small changes which have to be not desired for communicating purpose. The rhombic antenna is much easier to construct and maintain the other antennas of comparable gain and directivity only for supporting poles of common. That means if you design a high gain, high directivity antenna. So we use this type of rhombic antenna we have to be suggested in a wide frequency range 3 to 30 megahertz. It is highly directional and broad antennas with greatest radiated or received power along the main axis. So that means what is the significance of this? So in a wide band 3 to 30 megahertz, very high power is to be transferred in a over the operating frequency band, and very much less power is to be radiated in terms of the heat, or we can say lost power. So the efficiency of this type of antenna is high, because the efficiency, what is the antenna efficiency? Antenna efficiency is radiated power upon total power. So efficiency, how we calculate it? Radiated power I square RR, radiated power upon total power, that means radiated power plus lost power. So in this type of antenna, the lost power is very less or we neglect it. So this type of antenna having a efficiency of 90 to 95%. So we can say this is the main feature of antenna, and its input impedance is twice, so that achievable of a single side radiator. So if I can say if the input impedance is high, so we calculate it, that means R1 and parallel to R2. So what is the R total? R1 R2 and R1 plus R2. So the total resistance is to be decreased. So this is to be aligned at, so we want this resistance is to be matched to the load impedance. So in this sides only single side of radiators work. So if I want only single side radiators to be work, so we increase the input impedance of the that particular antenna. So this is the references JD Cross antenna and wave propagation, which is suggested I have to view. This is McGraw-Hill publication. This is the second reference book, and this is the first reference book I have to be shared with. Thank you.